In example 77, we're going to just compare the notions of two events being mutually exclusive versus what it means if they're independent. And we're going to do it by just considering what the Venn diagram looks like. So let's start with mutually exclusive. So if A and B are mutually exclusive events, then their Venn diagram cannot allow for A and B to overlap. Right? Remember that if they're mutually exclusive, A and B must be disjoint. Or in other words, their intersection must be empty. Right? So they can't overlap at all. Now let's think about when A and B are independent. So considering A and B to be actual events that have some probability of occurring, if they are independent, we'll see that A and B must overlap. And the reason is because if not, then that would force the probability of A given B to be 0, right? And so if B is an actual event that has some probability of happening, its probability wouldn't be 0, and likewise for A. So their Venn diagram must allow for an intersection. Right, and again, just going back to this whole idea, if they did not overlap, the probability of A given B would be 0, and that would not be equal to the probability of A if A is an actual event with some probability of occurring.